All right, we have a quick little lesson here to just reinforce the notion of phase shift. Because, again, sometimes we have no choice. We can't start the problem off here where we would like to. Time t equals 0, no phase shift. We're at position x equals a. Well, one device you can use to help you get the rotation and the phase shift correct in terms of the starting point is to think of a unit circle rotating counterclockwise, and the rotation will match the phase shift. So if you forget, you can simply put theta equals 0 at the 0 degree mark, the normal 0 degree mark. When we rotate to 90 degrees, that is going to be a positive phase shift of 90 degrees, meaning that if we look here at time t equals 0, if this is positive 90 degrees, the block is right in the center. So again, this is our projection of our rotational motion, which gives us our sine and cosine to our linear motion. And it just gives a nice, I think, visual way to think of phase shift. However you get the phase shift correct is really all that matters. So if the unit circle helps, that's wonderful. So let me leave this here. We can take a look at this. You never introduce a phase shift if you don't have to. You always start it out at position 0. If you are a more mathematical person with your trigonometry, let me go back to our page here where we have our position function. So here, to just emphasize, no phase shift, right? We're at position A at time t equals 0 because we have time here on our x-axis. Well, if instead of starting at position positive A, positive x max, we started here, that would correspond to a phase shift of plus 90 degrees, or pi on 2. Now, I know there's two different ways to think about this. You can think of shifting the starting point, the 0, to the right, and as a physicist, that is my preferred way to handle the phase shift. Another way to handle the phase shift, I realize mathematically, is to take the function, to leave the x-axis stationary, and pull the function back, and have the starting point, the function itself, go back to a time t equals 0. So whichever way you are most comfortable with, as long as you will know physically what it means when a phase shift is introduced into a problem, that is all that matters. The most important thing, from the physics perspective, of course, is that it's the starting position, right? It's the starting angle in our solution x equals a cosine omega t plus 5, because when you plug in t equals 0, you have only the phase angle left. So again, I am going to zoom out here. I'm going to leave that for you to annotate this page of notes. Never introduce the phase shift unless you have to. But if you have to, you have no choice, and you need to be able to understand it.